All right, so we are going to do number 12. The weight of an organ in adult males has a bell-shaped distribution. So I'm going to draw that. They said it has a bell-shaped distribution, so I will draw the shape. Bell-shaped distribution with a mean of 340 and standard deviation of 15. Use the empirical rule to determine the following. About 68% of organs will be between. You know, when you're told 68%, you already know it's plus or minus 1 standard deviation. So what you're going to do is add 15, the standard deviation, to the mean. And you have 340 plus 15, 355. 1 standard deviation below the mean, 340 minus 15, 325. And this area is 68%. So that's the easiest question there. You don't even need to use your calculator. But if you do, if you want to put it in calculator, you get the same answer. What percentage of organs weigh between 295 grams and 385 grams? So all you need to do is find the number of standard deviations here. And find the number of standard deviations here. You can standardize it if you want to. So let me standardize the right side. Value 385 minus mean 340 divided by standard deviation. Standard deviation is 15. If I subtract this, I have 45. 45 divided by 15 is 3. So I have, I hope you know that this first question here, you should write it here. Okay, so what percentage of organs were between, so this is 3 standard deviations above the mean. And if I check this one, it's going to be negative 3 standard deviations above the mean. And you already know that empirical rule says plus or minus 3 standard deviations lie within 99.7. The empirical rule says 68, 95, 99.7 plus or minus 1 standard deviation, plus or minus 2 standard deviation, plus or minus 3 standard deviation. 14. A highly selective boarding school will only admit students who place at 2.5 standard deviations above the mean. So that is a normal curve. So if you take this exam, you cannot get admission into that school until you score 2.5 or above the mean. So they gave you z-score. All right. On the standard score, they give you that the mean is 100 and standard deviation is 20. We'll say its population standard deviation is 20. Therefore, I want to know what 2.5 is. You can do it by hand or you can write an equation. Let me write an equation. Z is equal to x minus mean divided by standard deviation. But you can do it by hand actually. 1 standard deviation above the mean, you see that standard deviation is 20. So 2 standard deviations above the mean is 40. 0.5 is it's going to be 50. So actually, this here is 2.5 standard deviation above the mean. So that is 100 plus 50. But how else can you do this? Suppose you don't know that you can use the empirical rule. You can actually do it by calculation. So you're given that the z-score is 2.5. So 2.5 standard deviations is equal to the value, the score in that exam, minus the mean. Mean is 100 over the standard deviation. Standard deviation is 20. And then you solve for the equation for x. Cross multiply. 2.5 times 20 is 50. So I write 50 here is equal to the score you make in that exam minus 100. The plus 100 on both sides because I'm solving for x. I have 150. Therefore, 2.5 standard deviation is at the point 150, which means for you to be accepted in that school, you must score 150 or above. So if they tell you that the mean is 100, you're aiming at the mean, you will not pass that exam. You will not be accepted in that school. They only accept those who scored 2.5 standard deviations above the mean. So you have to be so smart that you score 150. You are so much above 2.5 standard deviations above the mean. So the person has to score 150 or above to be accepted in that school.